We've seen that a process can be running, or it can be terminated, or in this zombie state where it's terminated but its process ID has not yet been reaped. It turns out there's one more state that we haven't mentioned. A process can be in a stopped state. And a stopped state means the process still wants to run. It's not finished, but it's not going to continue running until it is continued. Right? And the way that you stop and start a process, it turns out we just use the signal mechanism to do that. So the signal SIGSTOP, it's one you can't change the handler for, and the default handler causes the process to be stopped, to go into the stop state, whereas SIGCONTINUE, that takes a process, the default handler takes the process that was stopped and makes it continue again. And you see this when you use a shell when you type Control-Z. If you type Control-Z, that takes the current process and it stops it and gives you the shell prompt back, but the process still exists. So let's look at this example here. Let's run bin cat, and cat reads from standard input by default and prints back out to standard output by default. So if I type hello, it just gets echo, and echo gets echo. If I type Control-Z, then the shell has stopped the bin cat process. And if I use ps to grep for bin cat, then, well, it turns out I did this earlier, so I've got a couple of bin cats that are both in state T. T means the process is stopped. This number 8 here that my shell printed back to me, that says if you use fg%8, fg is not a program, it's a shell command, that means continue the process and make it the foreground again. So I can do more echoes at this point. I can hit Control-Z to finish the cat process. So again, Control-Z, it's actually sending SIGTSTOP instead of SIGSTOP, but the default handler is the same for that signal. T meant stopped there, and foreground is a way of continuing it. So if you're writing a shell and you need to control jobs, then SIGCONT and SIGSTOP are useful. SIGCONT and SIGSTOP are useful signals. The shell also needs to know when something went into the background so that it could print stopped right here. SIGCHILD, it turns out, is also sent to a parent progress whenever a child stops or continues. So it turns out a lot of the programs that I wrote before in this sequence of videos, where I just assumed that a sequence meant that a wait would succeed, that wasn't actually true. They were broken in a different way. If you use wait or wait PID, you don't get information about stopping or continuing by default. If you want that information, you have to use wait PID, and you have to use W untraced to get stopped information and W continued to get continued information. And when you use wait PID with these flags, you have to check the status. If stopped is true, that means wait reported back that the process is still running, still can continue to run, but it has been stopped. And if if continued meant there was a change to the status of the process and it is now continued. These are not things that you usually need, but if you're writing a shell yourself, or some shell scripting language, as you will in the lab assignment, then you will need these options of wait PID to implement it completely.